Hi my dear students, today we will discuss about arithmetic instructions. In the last class I discussed about data transfer instructions. So now we will go for arithmetic instructions. This first instruction is ADD, add. When we want to perform addition operation, then we use this instruction ADD. So what is the syntax? Syntax of addition instruction: ADD destination comma source, destination comma source, right? So these instructions add a number from some source to a number in some destination and put the result in the specified destination. Put the result in the specified destination, right? When we are performing addition operation, some flags will be affected. Some flags will be affected. This one I told when I discussed about flag register of 8086. So what are the flags are there in the flag register of 8086? So that is auxiliary flag is there, carry flag is there, overflow flag, parity flag, sign flag, zero flag. 6 status flags are there. Those status flags will be there. So when we are performing this arithmetic instruction, these flags, some flags will be affected. So when we are performing this addition operation, so what are the flags will affected? What are the flags will be affected? So the flags will be affected flags. Affected flags. What are the flags will be affected? Auxiliary flag, first one, then carry flag, then overflow flag, parity flag, sign flag, and zero flag. These flags will be affected, right? Now coming to the example. Now we will consider one example, right? So what is the example of addition instruction? Let us consider add AL comma 73H, right? So you tell me AL, how many bit register? AL is 8-bit register. AL is how many bit register? AL is 8-bit register. A73 is 8-bit data. 8-bit data. 73 is added with the content of AL. Added with the content of AL. Now let us consider one simple program, that is move AL comma 24H, right? Add AL comma 73H. So what will be the addition? You please tell me. When we are performing execute this program, what will happen first? When you execute this, the AL will be loaded with 24. The AL will be added with 24. Then after that, add 73 with this AL, 73H with this AL. Initially in AL, how much data is there? 24. Now we add 73. 4 plus 3 is 7, 7 plus 2, 9, 9, 7, 8. Right? So the output is where 9, 7. Where the output result will be stored? The result will be stored in this AL. Remember, the result will be stored in the destination. The result will be stored in the destination. This is very, very important. So then what happened? AL is equal to how much now? 9, 7, H. Right? 9, 7, H. Right? Same. This is which addressing mode? What I am telling, this is which addressing mode? Please tell me. This is immediate addressing mode. This is which addressing mode? Immediate addressing mode. Now I am performing some another, right? Suppose add CL comma BL. Add CL comma BL. That means add content of BL with the content of CL. Add content of BL with the content of CL. Right? That is. Now another example. Now another example is add DX comma BX. Add DX comma BX. That means add content of BX to the content of DX. Content of BX to the add content of DX. Right? So what you have to remember is when we performing adding two 8-bit numbers, when we are performing adding two 8-bit numbers, the result 8-bit register may be sufficient, may not be sufficient, right? Suppose the maximum 8-bit number is saved is how much? FF. If you add FF with the FF, the result may not be a 8-bit, the result may be a 16-bit, right? So that's why you please remember. Suppose move AL comma FFH and add AL with FF. Will it be okay? No. Why? Because when you are performing FF, you add with FF. What will be the result? FF, you add. So what is the output? You please tell me. So the result will not be a 8-bit register. The result will not be a 8-bit register. So under condition, you have to mention 16-bit register. Under condition, you have to mention 16-bit register, right? So the destination must be a 16-bit register. The destination must be a 16-bit register. Then the result will be stored on two, AH and AL. AH and AL. That is very, very important. Right? In the same manner, when we are performing two 16-bit numbers, add AX comma BX. If both are maximum 16-bit numbers, the result may not be stored in the AX. Right? So it take another register. Which register we have to use? Then we have to use DX register. We have to use DX register. This is very, very important. Right? When we are performing two 8-bit numbers, the 8-bit numbers are same size. The destination 8-bit register is not sufficient to store the result. For that purpose, the result must be stored in the 16-bit register. And when we are performing two 16-bit addition, the result may not be a 16-bit result. So then the result may be exceed the 16-bit. Then we have to some lower order bit will be stored in the AX register and higher order bit will be stored in the DX register. Lower order bit will be stored in the AX register, higher order bit will be stored in the DX register. Right? This will be explained when I will explain about the simple programs. Right? Now coming to the next instruction. Next instruction is ADC. What is that? ADC. That means add with carry. ADC. Add with carry. Remember. So what is the syntax? Syntax is ADC destination comma source. ADC destination. It adds two operands. It adds two operands with carry flag. Initially what happened? Initially the carry flag is 0, no problem. The initially carry flag is 1. Then it adds destination with source and this carry flag also. Let us consider one simple example. Suppose let us consider initially the carry flag is set to 1. Initially the carry flag is set to 1 in the program. So then what happened? ADC 32 comma ADC that is AL comma 32. ADC AL comma 32. That means what? It adds with 32 AL plus 32 plus carry flag how much? 1. Then the result will be again stored in the AL. The result again will be stored in the AL. Right? In the same manner, ADC DX comma AX. It adds with AX. The output is what? AX plus DX plus 1 carry flag. The carry flag is 1. Otherwise, if the carry flag is 0, then you have to add with 0. Otherwise, if 1, it means add to 1. The result will be stored on again DX. The result will be stored in the destination. Right? This is about add with carry. Add with carry. Right? Next, third one. Third one is subtraction. Third one is what? Subtraction. SUB. The syntax is what? Subtraction. SUB. So syntax is, the instruction is SUB. The syntax is SUB destination comma source. SUB destination comma source. That means suppose see SUB CX comma BX. That means what? You please tell me. That means what? Sub CX CX comma BX. That means it is a CX minus BX. CX minus BX. Result will be stored in CX. Result is in CX. Result is in what? CX. Now, what are the flags will be affected? What are the flags will be affected? So, if the flags affected is auxiliary flag, carry flag, overflow flag, parity flag, sign flag and 0 flag. Parity flag, sign flag and 0 flag. Right? Also we can write using offset address, subtract AX comma BX. The content of BX and AX. AX is subtracted with the content of BX. Right? That is. Now coming to the next instruction. The next instruction is SBB. Next instruction is what? SBB. Subtract with borrow. SBB. Subtract with borrow. Remember. So subtract with borrow means suppose SBB. Same syntax is destination comma source. Destination comma source. Right? Now coming to the example. SBB AL comma 74H. AL comma 74H. With borrow also it affected. So what are the affected flags? Affected flags. What are the flags will be affected is auxiliary flag, carry flag, overflow flag, parity flag, sign flag and 0 flag. Parity flag, sign flag and 0 flag. Right? Subtract the word from effective address. You can also do like that also. That is SBB CX comma some indicator. Like let us consider table consider of BX. That means what? Subtract the word from effective address, table content of BX and status of CF from CX, carry flag from CX, right? So that is the indication. So that is about what? Subtract with borrow. Subtract with what? Borrow. Now coming to the next instruction. Increment. This is very, very important. Increment. Right? It increments by one position. It increments by one. It increments the byte or word by one. It increments the byte or word by one. What is the syntax? Syntax is increment source. Increment source. Which flags will be affected? See, in this increment, what are the flags affected is AF, OF, overflow flag, parity flag, sign flag, 0 flag. Which flag is not affected? See, these are the affected flags. These are the affected flags. So which flag is not affected? Remember, this is very, very important. Increment. Not affected is carry flag. Which flag is not affected? Carry flag. So maximum in the problem you will write like this: increment SI. We will give some location, then we have to give that location to the SI, right? Simply we are giving some offset address. Offset address initially we will assign like this: move SI comma 1000 H. Now suppose see, this is the offset, this is the data segment. Here some location is there. This is 1000 H. Now I want this location, increment this location. Simply what I have to do? Increment SI. That means again which location will come? 001. 1001 location will come. Right? Same increment we can write like this also. Increment DI. Increment DI. Right? So like this will be happen. So which flag is not affected? Carry flag. Next, decrement. Decrement instruction. What is the syntax? Syntax is decrement source. Decrement source. It decrements the byte or word by 1. Right? The operand can be a register or memory location. The operand can be a register or memory location. Same. CF is not affected. CF is not affected. Remember, this is very, very important. CF is not affected. Which flags will be affected? Same as in subtract. Auxiliary flag, overflow flag, parity flag, sign flag and 0 flag. These flags will be affected. These flags will be affected. So what is the syntax? Same. Decrement DI or decrement SI. Decrement DI or decrement CI. So simple. The location, if you want, we are giving 1010 location. to the di initially. Move di comma 1010. When you perform decrement di, that means what is the output? Decrement di means then it is comes to 1009. Location comes to the 1009. Right? So that is. Now coming to the multiply instruction. MUL. Right? MUL. The instruction multiplies an unsigned byte in some source with unsigned byte in a register, or an unsigned word in some source with an unsigned word in AX register. The source can be a register or a memory location. Remember. So what is the syntax? The syntax is mul source. Right? The source may be a data or may be a memory location. Can be register or a memory location. When a byte is multiplied by the content of AL, the result is put in AX. Remember, when the byte is multiplied by the content of AL, the result is put in AX. When a word is multiplied by the content of AX, the result is put it in DX and AX register. Remember, this is very important. In the same manner, addition, when we are performing multiplying two 8-bit numbers, then the result will be stored in which register? AX register. When the two 16-bit registers are multiplying, then what happened? The result will be stored in both AX and DX register. The most significant byte of 16-bit result or most significant bit of a 32-bit is 0. That is carry flag, overflow flag, both will be 0. And auxiliary flag, parity flag, sign flag and zero flag are undefined after mul instruction. Right? So that is, if you take one example, multiply, see the instruction, multiply simple one source, but see this is the comparison between addition and subtraction operation. In addition what we are giving? Source and destination we are giving. In subtraction also we are giving source and destination. Here we have to give multiply only source, that is mul BH. That means by default it is multiplied by what? Multiply with AL with BH. Multiply AL with BH, where the result will be stored. This is 8-bit or 16-bit? 8-bit data. The result of 8-bit data multiplication is stored in what I told, stored in AX. Stored in AX register. Right? Say this is for 8-bit. If you go for 16-bit, multiply CX, MUL CX, then it is multiply with AX, multiply what? AX with CX, multiply AX with CX. This is 16-bit data. Two 16-bit data when we are multiplying, the result will be stored on where the result will be stored. The result will be stored in low word. Low word is stored in AX and low word is stored in AX and high word is stored in DX. The lower result. Low word is stored in AX, high word is stored in DX. Remember, this is very important. When we are performing multiply instruction, this is very important. Right? Now coming to the division. Next instruction. Division instructions. The syntax is div, same, source. Div, syntax is what? Source. So the instruction is used to divide an unsigned word by a byte or to divide an unsigned double word. Byte or double word. Right? So when a word is divided by a byte, the word must be in the AX register. Remember, when a word is divided by a byte means how many? 8 bits. Word means 16 bits. When a word is divided by a byte, the result will be, the word will be stored in the AX register. The divisor can be a register or a memory location. The register will be a location. Right? Now, suppose consider one example. Right? Div BL. That means what? So with what it will be divide word in AX with AX by byte in BL. Byte in BL. That means we are giving only source, same multiply, division, C. Remember, these two are the very important in total microprocessor. The addition subtraction was somewhat easy, but this multiplication division, the syntax are different. Division source. Here only we are giving only source, we are not giving destination. So where the result will be stored. So where with what, which one we have to divide? BL means word in AX. With AX it will be divided. AX is divided by byte in BL. Right? Now coming to the where the quotient will be stored. Tell me where the quotient. The quotient, see, the quotient is in AL. Remember, quotient is in AL, and remainder, the remainder is in AH. The remainder is in where? AH. That is very important. Suppose see 2, 5, 2 2s are 4, 1. Right? This 1 will be stored in AH, and this 2 quotient will be stored in the AL. Quotient will be stored in the AL. So that is the division instruction. That is what? That is division instruction. Same when we go for 16-bit div CX. Div CX. That means what? Divide downward in DX and AX by word in CX. See, divide downward in DX and AX by word. AX by word in CX. Now where the quotient will be? The quotient will be in AX. Quotient will be in AX, and remainder will be in DX. Remainder will be in DX. Right? So the next instruction is decimal adjust after addition. Decimal adjust after addition, DAA. And another decimal adjust after addition, and another instruction is decimal adjust after subtraction. Decimal adjust after subtraction, and next convert signed by to signed word, CBW. Convert signed by to signed word, and next convert signed word to signed double word. Signed word to CBD. Signed word to signed W. And next another one, ASCII adjust after addition. ASCII adjust after addition. This is what? DAA, decimal adjust after BCD addition. Decimal adjust after BCD addition. Next decimal adjust after BCD subtraction. Next convert signed by to signed word. Next convert signed word to signed double word. ASCII adjust after addition, and next ASCII adjust after subtraction. ASCII adjust after subtraction, like this. Next ASCII adjust after multiplication. ASCII adjust after division. ASCII adjust after division. In this, the main important what? Subtraction, addition, multiplication, division, increment and decrement. Increment and decrement. Right? So this is about today's class. In the next class, we go for what are those logical instructions. In the next class, we will discuss about logical instructions.